Hey, welcome to 6-1, Rate of Change. Congratulations on finishing up Chapter 5. Uh, Chapter 6 is awesome. We're going to learn a lot of real fundamental knowledge about algebra. I hope you enjoy it. I think it's got some fun aspects to it. So 6-1 is about rate of change. There's a really nice discussion in the text. You should read it. The big idea is right there. It says the rate at which a quantity changes can be determined either by computation or by looking at a graph. And we want to keep in mind that the rate of change is just that. It is a rate. So in the case of this baby example, it's in pounds per month. That's a rate. And so how that changes is it's a change per month. It's not simply the total change. So there is a difference between concepts when you're looking at those things. We could have both positive rates and negative rates of change. When a car is slowing down, that's a deacceleration, that's a negative velocity. So a negative acceleration, a negative change in speed. I'm going to go through some additional examples. I'll be pulling up the sketchpad here in just a second. Do want to remind you to read through this, work through the examples. If you have any questions, please ask. If you want to help with working through some of these, please let me know so I can help you out with it. So I'm going to go ahead and pull up the sketchbook. And here we are, Algebra Lesson 6-1, Rate of Change. And here's our first example. Example 1, the table below shows home attendance for one baseball team during the years 1998 to 2005. Find the rate of change in attendance in people per year during the given time and tell how the rate is pictured on the graph. Well, we don't have a graph, so we're going to have to just simply worry about finding the rate of change. So what are we looking for here? We're looking for from 1999 to 2000. What is the rate of change? Now we have to be careful here in this table. This is attendance in millions. So the change from 99 to 2000 was not 1.3 to 1.9. It was 1,300,000 to 1,900,000. So your answer for this one will reflect that kind of rate, that rate of change from those two values. So what's it going to be? It's 1,300,000 subtracted from 1,900,000, and 3 from 9 is 6. So 600,000 is our answer. 600,000. 0.6 million would not be an appropriate answer. We want this expressed as appropriately as possible. And since it went, if we were going to graph this from 99 to 2000, what would happen to the graph? Would it be flat? Would it tilt down, or would it tilt up? Well, we went from 1.3 to 1.9, or 600,000 change, and in doing that, that went up. So it would be a graph that would go upward. Right, we'll go with part B. So from 2001 to 2002, we find that we have the last thing that happened was 2002, so that's 1,700,000. 1,700,000. Remember, we need to rewrite this in terms of as what that number really is. So it's in millions. And we're going to subtract from that minus 1.8 million, so 1,800,000. And since we're subtracting a larger from a smaller, this is dealing with negative terms. So that's going to be a 7 from 8 is 1, a negative 100,000 is going to be our difference. So it changed in a negative way. It went from a positive change in part A to a negative change in part B. So in part A, it's 600,000 people per year is the rate of change in attendance, and for part B, it's a negative 100,000 people per year is our change in the rate of attendance. Another example, and this has to do with zero rate of change. I think as it sounds, zero rate of change is just that, nothing happened. So let's get this out of the way. Get this out of the way, and we'll pull up another problem. Okay, for additional example 2, the table below shows the daily gross sales at an automobile dealership for 1 week. So we got Monday through Saturday, how much sales they had. And our first question is A, on which 2 consecutive days did the gross sales not change? We take a look at that, and where did it not change in consecutive days? Well, that's pretty easy. It's right here at this Thursday, Friday, 99,000. And then find the rate of change in gross sales during that time. Well, that's going to be That's going to be 99,000 minus 99,000, and that's just going to equal 0. So the rate of change is $0 per day rate of change, and that's basically a zero rate of change problem. The textbook has some additional information that you might want to take a look at, and this is in the very last page of the lesson, where there is a table of different situations and what kind of rate of change is being indicated. We have a graph that's going upward as we go from left to right. That's a positive rate of change. The next one, constant decrease, the graph goes down as we go from left to right. That's a negative rate of change. And when it's just horizontal, like the horizon, it's a horizontal line, that's a zero rate of change as a horizontal line. Covering the reading, covering the ideas, applying the math, that's your work to do, followed by taking the mastery exam. Look forward to seeing you on that. Best of luck. If you have questions, let me know. Be glad to help out if I can.